forgot to give you a pretty important piece of information there. Okay, give that one a try. All right, so this is the kind of basic horizontally projected projectile type of question that we have. Okay, so we've got the person running off the diving board at 2.75 meters per second. Okay, from a vertical perspective, we know that the acceleration is 9.81 meters per second squared. The displacement vertically is 8.0 meters. And what else do I know? VI, what is it? It's 0 because they ran horizontally off. That is the thing that I have to remember if I'm going to get this question A, done, and B, correct. Okay? So that's what I have vertically. Horizontally, I only know one piece of information, and that is the horizontal velocity. It's 2.75 meters per second. Okay, I'm trying to find out how far they travel horizontally. What do I need? Okay, can I find that with the vertical information? Yes. Okay, and just like all the other ones that we've done, the formula we're going to use to do that is this one. Because I have D, I have VI, and I have A. All right? Since VI is 0, I can eliminate this part of the equation, because 0 plus anything is anything. Okay? And then I just need to manipulate to get T by itself. Sorry, it's supposed to be squared. Okay? That means I'm going to divide both sides by half of A, and then I'm going to square root. That will give me T. So T will equal the square root of 8 meters divided by 1/2 times 9.81, all square rooted. Okay, that's half of 9.81, by the way. All right, so it's going to take 1.27 seconds for it to fall, or for the person to fall to the water. Okay, so now that I have that, there was 1.27. Okay. Now I can go D equals V times T, 2.75 meters per second times the 1.27 seconds that we just calculated. All right, 3.5 meters, 3.51 meters from the base of the diving board. Actually, no, how many? I only have two significant figures. It's just 3.5. Sorry. 3.5 meters. Okay? Everybody all right with that one? All right? Because there's only a couple of ways I can ask a projected horizontally question. I can ask you to calculate how far from the base, how high is the cliff, or how fast did they run off. Okay? But in the end, it doesn't matter which one of those three things I ask. This is the formula you'll use with the vertical information, and this is the formula you'll use with the horizontal information. That's not going to change. Okay? Everyone all right with that? Okay. Let's give you a second one, but this one will be projected at an angle. few minutes on that one. Okay, so let's run through this one. So what we know is that the shell is launched at a 42-degree angle at 1,285 meters per second. It's going to follow an arc. It's going to have it re-encounter the ground over here. Okay? What we're looking for is the horizontal distance traveled and the maximum height. So we want to break this up into its vertical and horizontal parts. Okay. That 1,285 meters per second, vertical or horizontal? Neither. It's 42 degrees above the horizontal. I'm going to use it to calculate the initial vertical velocity, which is its vertical component, and the horizontal constant velocity, which will be its horizontal component. That's all I use that number for. I never use it again. Okay? And that's a very common mistake that I see. Okay? Is that people are trying to use this 1,285 for things beyond this very first part. All I do is use it to get my vertical component and horizontal component. After that, it's useless to me. Okay? Because it is not horizontal and it is not vertical. It is the actual projected velocity of the shell. Okay? So to get the vertical part, VI, that's the opposite side of this triangle. So VI will be the sine of 42 degrees times 1,285. Okay, now that's going to be sine of 42 times 1,285. So 859.83. Now, I rounded off, but I'm not rounding off in my calculator, and that's crucial. It's another mistake I see people make, and on your unit exam, it'll get you. Okay? You must keep all of your decimals in your calculator until the very end and then round. If you round off early, it'll cost you, okay? Because it'll make a difference in your calculations. All right, so this is my initial vertical velocity, which is up. If this object travels along this arc and hits the ground at the same height it was fired from, what's VF? Negative 859.83 meters per second. All right, and I also know the acceleration, it's negative 9.81 meters per second squared. All right, from a horizontal perspective, I can calculate how fast the object's traveling horizontally because it's the adjacent side, so cos of 42 times 1,285. So 954.94. meters per second. All right, I'm trying right now to calculate the horizontal distance traveled. What don't I have? Time. Can I calculate that with my vertical information? Is this the same way we've done it basically every other time? Should you expect to do it this way tomorrow? Okay. So, to calculate the time, VF minus VI over A. So that'll be our negative 859 minus 859 over negative 9.81. Obviously, I'm keeping all the decimals when I do that calculation. So going up here and grabbing that number, multiplying it by 2, and then dividing by 9.81. Okay, so this thing's going to be in the air for 175.29 seconds. Okay, and I'm going to keep all the decimals. So that number can come over here because it's the only thing the vertical and horizontal parts share. So D equals V times T. That'll be the 954 times 175. That'll get us our horizontal distance traveled. So again, I'm keeping all my decimals by doing it this way. All right, so this thing is going to travel very far. don't write that as an answer tomorrow. Very far will not be accepted. Okay, but it will travel 1 point, and we have 3 significant digits here, right? We do. 1285 has 4, but 42.0 only has 3. So we are looking at 1.67 times 10 to the 5 meters. Okay? In other words, 167 kilometers is how far this shell will travel. Okay? All right, that's the first part of the question. No, what's stupid is not listening when Mr. Codere is showing you something that's on the testimony. Okay, the next thing we have to figure out is what is the maximum height? That'll be the vertical displacement right here. What changes about my information right there? The time is half, and what else? VF is 0, right. All right, so my vertical velocity is now 0, okay? So VF equals 0 meters per second, and my time is now 1/2 of the 175 seconds, right? Now, 2 ways to do this. Okay, that's my preferred way to do it. It does involve a little bit of manipulation, but it's not hard. Okay, VF squared minus VI squared over 2A is my manipulation. So 0 squared minus 859 squared divided by 2 times negative 9.81. So okay, so that's 2 times 9.81 right there. All right, so it is going to reach a maximum height of 37,682 meters, but I only have 3 significant figures, so 3.77 times 10 to the 4 meters would be my maximum height there. The other way to do it, okay, the other way to do it is to use this formula here. D equals VI times T plus 1/2 AT squared, but what do I have to remember about T? It's half, right? Okay, so I'd be putting in here my 859 times half of 175, so what's that, 87.5 or something like that. Okay, if I punch that all in, so I'm going to take my VI, which was this number, and multiply it by that number. That's VI times T, plus 0.5 times negative 9.81 times that number again. Whoops, not divided. Times, and that number has to be squared. Okay, I get exactly the same number. And I should get exactly the same number. Don't do it both ways on the test. It takes too long. Okay, pick one for you. No.
When you're doing the significant digits, there'll always be like one variable in front of the decimal. That one would be like.
If you're putting it in scientific notation, yes. Okay, so scientific notation involves making really big numbers or really small numbers manageable. Okay, and when I write something in scientific notation, the base is always a number between 1.0 and 9.9. Okay, it should never be bigger than 10. Okay, it's not that this would be incorrect. 127 times 10 to the 2 is the same as saying 1.27 times 10 to the 4. But this is correct scientific notation. This is mathematically the same number as this, but this is proper scientific notation. So if you did it either one of those ways, both of those numbers have 3 significant digits, but this is more correct in terms of how I write scientific notation, right? Similarly, if I had this number, and I wanted to write it in scientific notation, okay, it would be 1.23 times 10 to the minus 1, 2, 3, 10 to the minus 3. Okay, because I knew the decimal places. Yeah. In our number system, every space is a factor of 10, which is why we write our scientific notation base of 10. All right, is that making sense to everybody? All right. Take a little break. At 1:25, we're back here and we're working on the rest of the projectile motion questions from the digital workbook. Okay, if you're headed out of the room, make sure you're back here and quiet in the hallway, please. Okay, so guys, I want you to finish up the projectile motion problems from your digital workbook. They start on page 9 and they go on to page 10. The first ones are all projected horizontally, okay, and they go up to question number 7. Okay, so 1 through 6 are all horizontally projected projectiles, and then 7 through 16 are the ones projected at an angle. It starts to get quite a bit more involved in, like, let's say 13 through 16 than you could expect to see tomorrow. And those would be beyond what I would ask you on a unit exam, but certainly between 6 and 13 would be aimed for your unit exam. Okay, as well as obviously 1 through 6 because they're horizontal. That'll be on there as well. Right? So working on those, the answers are on there. If any of those, if you want to request that we go over any of those together, that's totally cool. Just ask and we'll do it.
No, is there any way of getting the answers for the exam from the Untitled on that worksheet?
Did I not post them?
Or maybe you did, but they weren't like on there as usual. So I just wanted to like.
Well, no, they're not in there like that. I have a separate key file. Okay, guys, so as requested, I have put the key in, but I put it in with Friday's unit exam review. So if you go into the stream, okay, this is my review podcast, and right here